oceans and lakes. What is oceanography? Oceanography encompasses many areas of studies of the ocean. Geological oceanography, having to do with the components underneath the ocean as well as the shoreline area. Physical oceanography, studies of the waves and all the physical aspects of the ocean water. Chemical oceanography, the chemicals within it, molecules, atoms, all different areas that affect the ocean, as well as biological oceanography, all the animals and plants.
Oceanography is wide-ranging. Covers geological oceanography, studies the geology, such as the ocean crust, the continental crust, volcanoes, underground volcanoes, the mantle. Physical geography, as how do waves and water affect everything else. Chemical oceanography, this goes with pollution as well as natural oil that occurs in the ocean and other sediments. And biological oceanography, which most people think of as oceanography in general, sharks, whales, fish, all living things.
Now, our ocean, very economically, is extremely important to our livelihood as human beings. Not only do we do mining in it, over 26% of all petroleum comes from offshore oil rigs throughout the world, and 15% of our total food supply is made up of shellfish and fish.
Oceanography is a very important part of our economy, with 15% of the total food coming from the ocean for the world, as well as oil and even mining.
Other areas we study for with oceanography are coastal erosion. You can see this cliff is eroding where these houses are, and ironically, it's these houses here causing that. Before these houses were here, there was growth of plants and grasses that were absorbing the water. Now there's no more grass or plants absorbing, there's houses in the way, so the water runs off and causes the eroding of these cliffs. Shipping lanes. So much of our world economy is based on these cargo carriers going throughout the world from continent to continent. Ocean pollution affecting a lot of our living things, as well as natural hazards such as tsunamis and flooding.
Oceanography impacts many areas of human activities. Erosion, as we build homes, it causes more erosion because there's not land with grass and trees to absorb the water when it rains. Shipping, as so much of our shipping comes from other countries. Ocean pollution, and then natural disasters such as tsunamis and flooding.
What we have to understand is our solar radiation. We talked about the greenhouse effect, and 69% of incoming solar radiation is absorbed by the atmosphere. However, a lot of it is reflected back out into space. Not all causing the greenhouse effect, and that's because 3/4 of our Earth is covered by water, which reflects the water back.
Solar radiation is a very important part of the ocean. It's what heats the ocean. Keep in mind, 78% of our Earth is covered by water, and a majority of that is ocean. So when the sun hits, it is heating ocean for the most part, creating a lot of the currents.
Now, what is not reflected back gets absorbed in the ocean, and really we can only see to about light going into about 200 meters, which is about 600 feet. After that, it becomes twilight area from 200 meters to 1,000 meters, and that is the aphotic area. Photic meaning light, so it's aphotic. There's no light past 1,000 meters. There's too many microorganisms and sediment that cannot get in through there. So the reason this is important is the deeper we go, the less chlorophyll can absorb to make sugar from sunlight, and less photosynthesis.
The sunlight only goes about, probably about 600 feet in the ocean, 200 meters. There is so much plankton, microscopic organisms within the ocean. By the time you get to about 3,000 feet, it's completely dark, even at noon.
When we look at the ocean, we talk about two different areas, benthic and pelagic. Benthic is the bottom, whether it's a shallow shore or deep at the bottom. So remember, B for benthic, B for bottom. And the pelagic is the open area of the ocean.
Benthic and pelagic zones. Benthic is basically bottom, touching bottom. Anywhere along the ocean where it is touching the bottom is called benthic. Pelagic is open ocean.
Now, organisms, both land and animals, are classified by where they reside in the ocean. In the pelagic,
different organisms live within different parts of the ocean.
Animals, plants on the
What I want you to pay attention to is the
also
pelagic
their
division,
tidal
that's the
zones
open ocean,
for
and the
high tide and
benthic.
low tide. There's a
More
mesopelagic
importantly,
zone,
90% of all living things in the ocean live within the intertidal zones, which is the shallowest part of the benthic area.
Pelagic and then hadal-pelagic zone, which is actually no light at all. We also talk about the method of locomotion for organisms in the ocean. Plankton, it's not just plants. Plankton are free-floating or weak swimmers. Zooplankton, these are small microscopic, submicroscopic animals. Zoo meaning animal, plankton meaning, weak swimmers. And you can see some brine shrimp as well as some sand fleas, other organisms, even small seahorses. These basically are free-floating or weak. They go with the current. And then there's phytoplankton, which are plants that are plankton. And they, even though they're microscopic, they also create chlorophyll.
Plankton are free-floating or weak swimmers. There is zooplankton, which is animal plankton, and you can see in this picture here, there's even some microscopic shrimp, which you recognize. Phytoplankton. Phyto is Latin for plant. These are plants, even though they're microscopic, also have chlorophyll and do make sugar, as we talked about in our very first class.
And it's not plankton if they can swim against the current, whether it's fish or squids or octopuses, certain types of worms. This is called nekton. Nekton can swim against the current.
As opposed to plankton, there is nekton. Nekton are animals that can swim freely, have tails basically propel them. Jellyfish are also nekton. For the most part, though, considered fish, dolphins, whales, porpoises, anything with a tail that can swim on its own is nekton.
Benthic organisms, meaning bottom organisms. For plants, they only grow in shallow areas where sunlight lives, basically above the 200-meter arc. Benthic animals, such as starfish, usually live along the shore. And then there's deep sea benthic animals, which the only reason to see it here is there is a light from the deep sea bathyscope took a picture of it. I think this is a toadfish, so otherwise it's completely dark. And you can see it's very flat because of the great pressure it lives under. It's evolved this way.
Benthic organisms. Benthic meaning bottom, as we discussed a little while ago. Benthic plants only live along the bottom where sunlight gets in. Otherwise, it cannot produce chlorophyll. Benthic animals live along the shore, such as starfish. Deep sea benthic animals, such as the stonefish, live at the deep depths.
And speaking of pressure, you got to remember pressure in the ocean is basically all the weight of the water above you. Now, the farther down you go, the more weight is above you. And at sea level, where you're sitting, we have one atmosphere, and our atmosphere is roughly 60 miles, but straight up. But, the weight of it, we can push up and down it right now is ease. That's one atmosphere. But for every 33 feet you go down the ocean, you add another atmosphere of pressure. So you're 66 feet, that's 2 atmospheres. 99 feet, it's 3 atmospheres pushing against you.
Pressure in the ocean is simply caused by the weight of the water above you and all around you. Every 6 feet, you create about a tenth of an atmosphere. So when you go 60 feet, it's 2 atmospheres. The deeper you go, the more pressure there is.
Now, Now we talk about water in the biosphere. 97.6% is in the ocean. That's salt water. The remaining about 2.5%, 2.4% is fresh water, and that's what all living things need to survive, especially land animals. And where we get most of it is glaciers. That's glacier melt from mountains. That's 2.08%, 0.29% groundwater. Freshwater lakes, 0.009%. And what's important to look at here is how quickly it's refreshed. Glaciers, 16,000 years. It does not refresh. We use all that up. It'll take 16,000 years to renew. Rivers, 12, 20 days, because they're usually being fed by other areas. But the important thing to understand is, as we increase our population, we increase our growth, we increase factory output, sewage output, everything, we're using water greater rate than we ever did before. And you can see these renewal times take time.
Interesting chart here. While the ocean has 98%, 97.6 to be exact, of the water, nearly all living things on land can only drink fresh water, which is the remaining 2%. And most of this, you can see, comes from glaciers, with some from groundwater, and smaller amounts from fresh water, rivers, and the atmosphere itself.
Talk about freshwater systems. Running water is lotic, such as a river or creek.
Lotic systems is running water, rivers, creeks, and streams, water that moves.
If it's basically still water, it's lentic, lakes and bogs and ponds. Bogs, while they are, you could say you could walk through them, it's mostly perpetually muddy. That is considered an aquatic ecosystem. Marshes as well as swamps are also. Again, these are all lentic.
Lentic systems is water that does move. Lakes, swamps, ponds, as well as bogs and marshes where you may not see water, but there's perpetual water under there.
There's wetland environments. These are lentic as well, such as these swamps here.
Wetland environments, such as swamps, are also considered lentic environments.
We got 5 different kinds of lakes. The most common one we're used to is the shoreline lake, but there's the volcanic lake, which is basically an eroded volcano. It's almost perfectly round. That's what's left of that dormant volcano. Glacial lake, that's from mountains where there may be a cliff where the water cannot go over, so the water stays there. Landslide lake, usually landslides in the rivers that block the river up as a dam and creating a lake. And then there's tectonic lakes. We'll talk about plate tectonics later, where 2 tectonic plates, 2 continents run together, causing a tectonic lake.
Different types of lakes. Volcano lakes formed from old eroded volcanoes, usually perfectly round. Glacier lakes. These are usually in mountains where the glacier melt could not get past on the way down the mountain. It's too low. Landslide lakes, a landslide usually affecting a river and blocking it up. Traditionally, the shoreline lake, the most common one we see, and the tectonic plate, which we'll talk about in another class in geology, built on 2 different plate tectonics coming together.
Chemically, we have 3 types of lakes. The oligotrophic, these are highly acidic. These are these lakes you see like in the mountains where you see like 600 feet down. It's very clear. Very few things live in there because it's so acidic. Get some fish, but not in some organisms, but not that many. It's very clean water. It's very clear because not too many things can live in it, and that's because it's highly acidic. It is very clear.
Oligotrophic lakes are freshwater lakes that are highly acidic. That's why they're so clear. You can see all the way to the bottom from hundreds of feet sometimes. Very few things can live in here, though, because it is highly acidic.
Eutrophic. We see a lot of these in Georgia here. These are all the seaweed in here. And a lot of this is, there's a lot of decomposition of too much fertilizer going into this. And that causes all kinds of algae blooms. When they die, it sucks all the oxygen out, so nothing can live within this.
A eutrophic lake has high amounts of algae within it. The problem with the eutrophic lake, why it is highly living with algae, when some of the algae dies, it takes up all the oxygen, so the fish and other things cannot live within there.
Then there's this Trophic Lake. This is basically a chemical lake. It's got chemicals within it. You can see where it's bluish black and there's nothing living around it. This is actually in Yellowstone right here. It's coming probably from the hot springs under the ground here. But you see that it's dystrophic. Nothing can live in there at all.
A dystrophic lake. This is a poisoned lake, basically, usually from chemical runoff or from a mine. As you can see, this water is black. And look at the surrounding area. There's nothing living around it either. Very poisonous.
And with lakes, it does how it affects the environment goes beyond just the shoreline. There's usually a water table underneath that may go several feet or even a couple miles beyond that are feeding the trees and the plants along across the shore.
While a lake does end at the shoreline, where it starts, usually water underground goes on for a significant area beyond that, sometimes as far as a mile or more, called a permanent water table underneath.
As mankind's increased population, as I said before, we saw the sinkholes in another slide, we are reducing the amount of wetlands, which does do a lot of our water retention. Got maps here from the 1780s, 1980s. It's interesting, just look at a few states here. You look at Louisiana on the left and Florida on the left. They had 50 to 55% wetlands. They now have 25 to 50% wetlands. Look at Wisconsin and Minnesota and Michigan. They had 25 to 50% wetlands. They now have 12 to 25%. Again, this is mankind using more and more water to survive.
Our wetland reduction caused by increasing population as more and more people drink more and more water, as well as factories and commercial interests within water. These are maps from the 1780s to the 1980s, where you can see even areas like Florida, which was 50 to 55% wetland, is now 25 to 50%. Wisconsin, which is 25 to 50% wetland, is now 12 to 25%. And this goes throughout the entire United States. As you can see, the more humans we have, larger population, the more draining the water, faster they can be recuperated naturally.
Now remember, we talked about this before when we were talking about geography. Our tides with our oceans and even our lakes to a lesser degree are caused basically by the sun and the moon and its gravitational pull on each. Our highest tides are when the sun and the moon are on the same side, and we have two high tides and two low tides every day. High tides usually noon or on midnight, and then 6 in the morning, 6 in the evening are lower tides because that's where they're stretched out. And you talk about eutrophic problems. This is agriculture, basically fertilizer runoff. This is in Saudi Arabia here, going to the ocean. You can see even in the ocean, it's got eutrophication. A lot of this green algae blooming because of the excess fertilizer running off. And the eutrophication, basically the biggest problem is it comes from fertilizer as well as manure from cows and pigs and the other animals. The plants love it because they need the fertilizer. However, when they die, they absorb excess oxygen from the decay, and that takes oxygen away from all the other things that need oxygen. The microorganisms, the fish, the insects, and then nothing can live.
Eutrophication, as you saw with the Eutrophic Lake, more and more algae comes in, often created by the fertilizer overflow from farms and yards, and that causes more plankton. Unfortunately, when the plankton dies, it decays, sucks more oxygen out of the water, and then nothing else can live within it.